Hello everybody, welcome to Transy Learning Chemistry videos. Today we are going to discuss about the topic solutions, and in that we are going to cover up the topic expressing concentration of solution and their formulas. In this video we are going to discuss about the concept mole fraction, molarity and molality, and examples and the practice problems related to them, how to solve the problems related to mole fraction, molarity and molality. So let's start. Let us discuss about the molarity. Now the molarity is represented by the capital M, and that is number of moles of solute upon volume of solution in the liter. We know that the number of moles is equal to given mass upon molar mass. And when we are talking about the word solution, that means we are going to add up the solute as well as the solvent. That will give us the solution. The molarity is defined as the gram atoms or gram molecules of the solute dissolved in per liter or decimeter cube of the solution. Gram atom means we are going to talk about the moles of atom, and when we are talking about the gram molecules, that means we are going to talk about moles of molecule. Okay, and remember that 1 liter is equal to 1 decimeter cube, and 1 liter is equal to 1000 ml. So if we have to convert 1 milliliter into liter, we have to divide it by 1000, and the unit of the molarity, it will be equals to mole per liter. Now let us understand this with the help of an example. So this is the example. We have to find the molarity of a solution containing 4.9 grams of sulfuric acid dissolved in 250 ml of the solution. What is given to us? First of all, it is given that the mass of the sulfuric acid, that is given 4.9 grams, and the volume of the solution is given as 250 ml. It is clearly mentioned solution, right? We have to calculate the molarity. Molarity is equals to number of the moles upon volume of solution in liters. So now let us first calculate the number of moles. Number of moles is equal to given mass upon the molar mass. Given mass is 4.9 and the molar mass. So now how we are going to calculate the molar mass of sulfuric acid? Just see here. This is the molar mass of the sulfuric acid. How we are going to calculate? The atomic mass of the hydrogen is 1, the sulfur is 32, and the oxygen is 16. So that means the atomic mass of the hydrogen is 1 into 2 atoms, plus sulfur is 32 into 1 atom, plus 16 into the 4 atoms, because hydrogen has 2 atoms, so we are multiplying it with 2. Sulfur has just 1 atom, so we are multiplying it 1. Oxygen has 4 atoms, so we are multiplying it by 4. We are going to get the 98 grams. So now we are going to substitute the value. So the number of moles is equal to given mass upon molar mass upon the volume of the solution in the liter. We are going to substitute the value and find the molarity. In that case, the molarity will be given mass upon molar mass upon the volume of the solution in the liter. Now the given mass is 4.9 grams, the molar mass is 98 gram, volume of the solution in the liter. So we are going to divide it by 1000 to convert it into liters. So now we have 4.9 upon 98 into 1000 divided by 25. So on solving this, we are going to get 0.2 moles per liter, or we can write 0.2 molarity. Is that clear? So this is how we are going to calculate the molarity. Now let us do one more question on the molarity. A solution is prepared by dissolving 4 gram of NaOH to give 500 ml of it. Calculate the molarity of the solution. So in this case, what is given to us? That is the mass of NaOH, that is 4 gram, right? And the volume of the solution is given as 500 ml, and we have to find the molarity, right? So for the molarity, that is equal to number of moles upon the volume of solution in the liter. We have to first of all calculate the number of moles. that is given mass upon the molar mass. Given mass is 4 gram and the molar mass of NaOH will be equals to the sodium is 23 plus 16 plus 1. That will come out to be 40 grams. Okay, so here the number of moles will be 4 divided by the 40 grams. Now we are going to substitute the value. Number of moles is given mass upon molar mass upon volume of solution in the liter. Given mass is 4 gram, molar mass is 40 gram, volume of solution in the liter, that is we are going to divide it by 1000 to convert it into liter. We are going to get 4 upon 40 into 1000 divided by 500. So if we solve it, we are going to get the value as 0.2 moles per liter. Got it? We are going to consider the molarity of the solution on mixing two solutions. So in this case, we are mixing two solutions. Let us consider this is a solution 1 and let us consider this is a solution 2. Now when we are going to mix these two solutions, 1 and 2, then what will be the molarity of the mixture that we need to calculate. So in this case, we are going to assume let the two solutions be 1 and 2. So the volume of the solution 1 is V1 and the molarity is M1, and the solution 2 volume is 2 and the molarity is M2. So the resulting volume of the solution after mixing 1 and 2 will be V1 plus V2, which is given by V. Now the molarity of solution after mixing solution 1 and the solution 2 will be M1 V1 plus M2 V2 is equal to M3 into V1 plus V2. That means the molarity of 1 into the volume of one solution plus the molarity of the second solution into the volume of the second solution is equals to the molarity, total molarity of the mixture into the volume of first solution into the volume of second solution. So in short, you can calculate the molarity of the mixture by solving M1 V1 plus M2 V2 upon V1 plus V2. Okay, this is the molarity of mixture of two solutions. Is that clear? Now let us do one example based on this. So here, what is the molarity of the resulting solution obtained by mixing 2.5 liter of 0.m urea solution and 500 ml of 2m urea solution? Let us consider here solution 1 and solution 2. Okay, here the volume 1 is given as 2.5 liter and the molarity 1 is given 0.5. Volume 2 is given 500 ml and the molarity 2 is given as 2m. Okay, so first of all, you have to convert this into the liter, that is 500 divided by 1000. This will come out to be 0.5 liter. This is very important. You have to calculate the molarity of the resulting mixture. That will be equals to M1 V1 plus M2 V2 divided by V1 plus V2. So in this case, 2.5 into 0.5 plus 2 into 0.5 upon 2.5 plus 0.5. Now when you are going to solve it, you are going to get 0.75 molarity. This is the molarity of the mixture of two urea solutions. Summarize the molarity and the molality. So one of an important factor is the temperature that I'm going to tell you. So first of all, what is the molarity? It is given by capital M. Molality is given by the small m. The ratio of moles of the solute to the volume of the solution in the liters, whereas in the molality is the ratio of solute to the volume of solvent. This is very, very important. Here we are going to consider the solution. As I've told you, the solution is solute plus solvent. Here we are going to consider the solvent in the kilograms. Here we are going to consider the solution in the liters. The symbol is capital M, here the small m. So the formula is number of moles of solute upon a solution in the liters, whereas this is the number of moles of solute, and here the solvent is in kg. The factors on which the molarity depends is the volume of the solution, atmospheric pressure, and the temperature of the solution. So the molarity is temperature dependent. This molarity is temperature dependent, whereas the molality does not depend upon temperature. Is that clear? Because we are talking about the mass, and that too in kilograms, and we are not talking about the volume. Volume is always temperature dependent, whereas mass is temperature independent. Here the units will be mole per liter, here the units will be mole per kg. This video ends here. Thank you very much for watching this video. In our next videos, we are going to discuss about more practice problems on mole fraction, molarity, molality, and the concept in practice problems about the mass percentage, volume percentage, parts per million, volume, and mass percentage. And then we are going to discuss about the Henry law, Rawls law, vapor pressure, elevation in boiling point, depression in freezing points, osmosis, osmotic pressure, Van 't Hoff factor, and many more topics. For more videos, you can visit our YouTube channel, Trans E Learning. Have a great day.